The activities which we discussed in the previous case was burning of magnesium ribbon. A chemical reaction has taken place. Now, we can represent this chemical reaction in the form of words. Let us see how. Magnesium, when it is burnt in air, it will combine with the oxygen present in air. So, we can write here oxygen, and it forms a white powder. What is that white powder? It is magnesium oxide. So, this is, we are representing the chemical reaction with the help of this equation. This is called word equation. Chemical equation which represents a chemical reaction briefly in words is called a word equation. One more activity we performed. What was that? Reaction between zinc and dilute sulfuric acid. That also we can write with the help of this. Zinc plus hydrochloric acid forms zinc chloride and a gas, which gas? Hydrogen gas, which is evolved, which we tested with the help of burning matchstick. So, when the chemical reaction is represented with the help of the words, it is called word equation. The substances which are taking part in the chemical reaction like magnesium and oxygen are called reactants. The reactants in this activity are magnesium and oxygen. Reactants are always written on the left hand side. The substance formed during the chemical reaction is called products. Here, can you tell me what is the product? Product is magnesium oxide, and the product is always written on the right hand side. If the number of reactants or products is more than 2 or equal to 2, here in this particular case it is 2, a plus sign has to be written in between the reactants. Here it is only 1, here it is 2. So, if the number of reactant or product is 2 or more than 2, a plus sign is written in between. Then an arrow is placed between the reactants and the products, which indicates that the reactants have converted into the products, or we can read it as to form. Magnesium reacts with oxygen to form magnesium oxide. So, this is how we write the word equation. In this second activity, here you can see zinc and hydrochloric acid are the reactants and are written on the left hand side. Because the number of reactants are 2, a plus sign is to be written in between, right. Then arrow. Arrow indicates that reactants are converting into the products. The products are zinc chloride and hydrogen gas. Because again the products are more than 2, a plus sign is written in between. So, this is how we can write the word equation. Word equation can be represented in a simpler way by writing the symbols and formula of the substances taking part in the chemical reaction. If you know the symbols of the elements or compounds taking part in the chemical reaction, you can write the chemical equation in a much simpler way. So, let us see how. In the first activity you have seen that magnesium ribbon reacts with the oxygen present in air and forms magnesium oxide. Now, if you know the formula of magnesium, oxygen and magnesium oxide, you can write the chemical equation, right. What is the formula of magnesium? It is Mg, okay. What is the formula of oxygen? O2. And what is the formula of magnesium oxide? It is MgO. So, we can write the chemical equation now. Mg for magnesium, O2 for oxygen and MgO for magnesium oxide. So, this is a chemical equation. In the second activity, zinc reacts with hydrochloric acid and it forms zinc chloride and hydrogen gas. So, you should know the formula of zinc. What is the formula? Zn. And what is the formula of hydrochloric acid? It is HCl. And the formula of zinc chloride, ZnCl2. And what is the formula of hydrogen? H2. So, we can write the equation in that case also. The chemical equation Zn plus HCl gives ZnCl2 plus H2. So, these are the chemical equations. Now, we can define chemical equation. What is a chemical equation? It is a method of representing the chemical reaction with the help of symbols and formula of the substances taking part in the chemical reaction. Of course, these equations are not balanced, that we will discuss later. Number of atoms of each element on both sides are not equal, that we are going to discuss right now. In the chemical equations we have discussed Mg plus O2 gives MgO. Now, if you count the number of atoms of magnesium and oxygen on the left hand side, on the reactant side, magnesium atom is 1 here, and now count the number of magnesium atoms on the product side, it is 1 here. So, number of atoms are same. Now, count the number of oxygen atoms on the reactant side. Oxygen atoms are 2 in number. Now, count on the product side, number of oxygen atom is 1 here. Number of atoms of oxygen are not equal on both sides. So, such an equation is called unbalanced or skeletal equation, skeletal or unbalanced equation. Similarly, in this particular case, let us see what is the status. Zinc atoms on both sides are equal, that is equal to 1. See the hydrogen atom. Hydrogen atom on left hand side is 1 and on right hand side it is 2. So, they are unequal. See the chlorine atoms now. Chlorine atoms on left hand side is 1 and on right hand side is 2. So, this equation again is a skeletal equation or unbalanced equation. Now, how to balance a skeletal or unbalanced chemical equation? You have studied in 9th class about law of conservation of mass. Now, what is that law of conservation of mass? Mass can neither be created nor destroyed. What does it mean? That total mass of reactants, total mass of atoms of each element in the case of reactants should be equal to the total mass of atoms of each element on the product side, or we can say the total atoms of each element, total number of atoms of each element in the reactant side should be equal to the total number of atoms of each element in the product side. According to law of conservation of mass, mass can neither be created nor destroyed. So, we need to balance the skeletal equation or unbalanced chemical equation. Now, let us see what is a balanced chemical equation. When the number of atoms of each element of reactants is equal to the number of atoms of each element of products, the chemical equation is said to be balanced. Now let us see how to balance the chemical equation. For balancing, a method can be used which is known as hit and trial method. Now let us discuss what are the various steps of this method. Let us take an unbalanced chemical equation which we have done in the previous activity. Mg plus O2 gives MgO. Now first of all, first step is to draw the boxes around the formula. We cannot change the formula or the symbol to balance. Nothing can be written inside the boxes. So first step is to draw the boxes outside the symbols and the formula of the reactants and the products. Second step is to make the table of the elements which are present in the reactant side and the product side. Now let us see what are the elements. Magnesium is one element, and what is the second element? Oxygen. So there are two elements, magnesium and oxygen. We can write this equation again just to now count the number of atoms of each element in reactants. Magnesium, how many atoms of magnesium are there? On the left hand side there is one magnesium atom, we can write here 1. And how many oxygen atoms of oxygen? On the LHS side there are 2, O2, 2 is written as subscript. So there are 2 oxygen atoms. Count the magnesium atoms on the right hand side. How many magnesium atoms? 1. And how many oxygen atoms? You can count for yourself. 1. So what do you think? Is the equation balanced? It is not balanced, because the number of oxygen atoms on both sides are not equal. Also we know that we cannot write anything inside the box to balance the chemical equation, to balance the number of atoms on both sides. We cannot write. Outside we can write as coefficients. So that is the step 3. We can write any number outside the box to make the number of atoms equal on both sides. So what can we do? If we write 2 here outside the box of MgO, we find that the oxygen atoms become equal to 2. 2 into 1 equal to 2. So number of oxygen atoms have become equal. We can do it like this also. Oxygen atoms have become equal to 2, but 2 is outside the bracket, 2 is outside the box, and it also makes some number of magnesium atoms equal to 2. So here right hand side number of magnesium atoms also have become equal to 2. To make the number of atoms equal to 2 again on the left hand side, we need to rebalance magnesium. How to do it? By writing 2 in front of the box of magnesium, which makes the number of magnesium atoms also equal to 2. Now we can check again. Magnesium atoms on both sides of the equation, on the left hand side as well as on the right hand side, is equal to 2. And oxygen atoms on both sides are also equal to 2. So, this equation is balanced finally. So, step 4 was to balance the magnesium atoms, to rebalance in fact. So, this is how we can balance. Let us take one more example. Fe plus H2O gives Fe3O4 plus H2. Now, in this case also, first of all, make boxes outside the formula or the symbols. Nothing can be written inside the box, no number can be written inside the box to make the number of atoms equal on both the sides. The first rule is that we have to start with the atom with higher number. Here the higher number of iron atoms are there, oxygen atoms are there. So, we will balance from that. But before that, first of all, after drawing the boxes, we will make the table. Elements, how many elements are there? There is iron, then there is hydrogen, and then there is oxygen. Is it okay? Then you have to count the number of atoms of elements of reactants and number of atoms of elements of products on the right hand side. Right. Iron atoms on the reactant side it is equal to 1 and on the product side it is equal to 3, Fe3. 3 is written as subscript. Hydrogen H2, it means there are 2 hydrogen atoms on the left hand side. See, on the right hand side there are 2 hydrogen atoms. Oxygen atom on the left hand side is 1 and on the right hand side, see, O4, 4 is written as subscript. So, there are 4 atoms. The equation is unbalanced. We need to balance the chemical equation. How will we balance? As I told you earlier, we will start with this iron and oxygen, which are higher in number. So, to make the number of iron atoms equal on the reactant side, if we multiply it by 3, the iron atoms will become equal on both sides. So, we write 3 as coefficient outside the box. So, now we have 3 iron atoms on LHS side and also 3 iron atoms on the RHS side. Now, oxygen atoms, let us see. Oxygen atoms on the product side is 4 and here it is 2, it is 1 only, right. Here it is 4. So, how to make them equal? By multiplying it by 4. So, if we write here 4, we can see that the oxygen atoms are also equal on both the sides, but what change has occurred? Here when we multiply H2O by 4, what happens? Hydrogen atoms have become equal to 4 2s are 8. So, this has changed, 2 into 4 equal to 8, right. The change has occurred. Now, we have to balance hydrogen atoms on the right hand side. How? By 4 2s are 8, by multiplying it by 4. So, if we write here 4, the number of hydrogen atoms also will become equal on both the sides, that is equal to 8. Now let us see again, check the equation again. 3 iron atoms on both sides, Fe3. This means there are 3 iron atoms. Here it is written 3 outside the box. This also means there are 3 iron atoms. 4 2s are 8. Here also 4 2s are 8, there are 8 hydrogen atoms. Then how many oxygen atoms? 4 into 1, that is 4 oxygen atoms on the left hand side, and here also O4, that is 4 oxygen atoms on the right hand side. So this shows that the equation is balanced. So by this hit and trial method, we can balance the chemical equation. Also this thing has to be kept in mind that the formula or the symbol of the element or compound cannot be changed or altered. You cannot write anything as subscript, only you can write anything, any number outside as coefficient to balance the number of atoms. Practice balancing of chemical equation by this method, hit and trial method. So these are certain equations. PbNO3 whole twice gives PbO plus NO2 plus O2. You can balance it yourself for practice. MnO2 plus HCl gives MnOCl2 plus Cl2 plus H2. Zn plus H2SO4 gives ZnSO4 plus H2. So do the practice and balance these chemical equations. Now we will discuss another method for balancing of chemical equation. This method is based on the number of times the atoms of an element occur in a chemical equation and the atomic number of elements. For this you can remember some of the elements with their atomic numbers. So at least few you know which are commonly used, like in increasing order from 1 to 20 atomic numbers. I think you know what is atomic number? Number of protons present in an atom. H, He, Li, Be, Bc, No, F, Ne, Na, Mg, Al, Si, Ps, Cl, Ar, K, Ca. So these are all the symbols of the elements written with their atomic numbers from 1 to 20. So if you memorize this, you can use this method for balancing of chemical equation. Another thing which you have to keep in mind is the frequency or the number of times the atoms of an element occur in the chemical equation. That is called frequency number or F number. I will explain here with the help of this how many number of times, let us say, copper appears in this equation at one place and at the second place. So 2 is the frequency number or F number of copper. You have not to count the number of atoms present in the equation or in the formula. Only you have to time how many times the atom is appearing in the chemical equation. That gives the frequency number or F number. So for balancing by this method, first of all we have to list the name of the elements present in the chemical equation. So let us see how many elements are present in this equation and what is their name. So the element, you can see yourself, copper is there, so we will write here copper. The other element is hydrogen, so we write the symbol here. Then sulfur is present, so sulfur we write here. Oxygen is present, so oxygen we write here. Now to find out the F number or the frequency number, what we will do? We will just count how many times copper is appearing in this chemical equation at one place and at second place. So the frequency number of copper is 2. We will write here in front of this column. Now see hydrogen. Hydrogen is appearing here 1 and 2. 2 times it is appearing in the chemical equation. So the frequency number or F number of hydrogen is 2. Again I will tell you, do not count the number of atoms, only you have to count the number of times the element is appearing in the chemical equation. Then sulfur, let us see sulfur. At one place then second place, and then the third place. So, what is the F number of sulfur? 3. Now, see oxygen, how many times it is appearing in the chemical equation? 1, 2, 3 and 4. So, count it yourself, and 4. I hope it is clear. Just you have to count the number of times an atom of each element is appearing in the chemical equation, gives us the frequency number, which we have written in this table. After doing this, we have to find out in which order we have to balance these atoms in the chemical equation. Now, how to find out in which order we should start balancing? Now, for this we should start balancing the chemical equation from that atom of an element which has least frequency number. That is, least frequency number here is 2, but hydrogen also has least frequency number 2. So, in case two elements have the same frequency number, in case of metals, the balancing of that metal will be done first which has the highest atomic number. So, in these two cases, copper is a metal and has a higher atomic number. So, we will start balancing copper first. So, we will write the order. So, it has to be balanced first and hydrogen has to be balanced second, and then in increasing order of frequency number we will balance the other atoms. So, the order of balancing of sulfur is third and that of oxygen is fourth. So, after completing this table, now we can start the balancing of the chemical equation. First of all, we have to balance copper. Now, you can see copper atoms on left hand side is 1 and on the right hand side is also 1. So, it is already balanced. The next is hydrogen to be balanced. Hydrogen on left hand side is 2, on the right hand side also it is 2. So, number of hydrogen atoms on both the sides are equal. Now, we start with the sulfur. Third element to be balanced is sulfur. On the left hand side there is only one sulfur atom, and how many on the right hand side? 1. Now, we have to count 1 plus 1, that is 2. 2 sulfur atoms are there on the right hand side. So, to balance these sulfur atoms, what we can do? We can write 2 in front of the formula. Here again the same rule applies, that we cannot alter, we cannot change the formula of or symbol of any of the element or compound. Simply we can write any number in front of the formula to balance. So, which it completes, it equalizes, it balances the number of sulfur atom. Now, there are 2 sulfur atoms on both the sides. The fourth atom which has to be balanced is oxygen. On this side now, already it is O4, already there are 4 oxygen atoms, multiplied by 2 it will become 8. So, on left hand side there are 8 oxygen atoms, and let us see how many on the right hand side. Yes, one more thing you will notice here, by writing 2 here, not only we have balanced sulfur, number of hydrogen atoms also has increased, which we have already balanced, which makes the hydrogen atoms unequal on both sides. So, we have to rebalance hydrogen, right. It has become 4 and it is only 2 here. So, to balance, to rebalance hydrogen atoms, we will write 2 here. So, now we have 4 hydrogen atoms on both sides. Now, we come to oxygen. 8 oxygen atoms on left hand side, count the number of oxygen atoms on right hand side. O4 means 4 oxygen atoms plus 2 oxygen atoms, 6 plus 2 oxygen atoms, 8. So, on both sides oxygen atoms are equal and the equation is balanced. So, let us take one more example just to have some practice, and there is one more rule which will be followed in this second example. The equation is PbNO3 whole twice gives PbO plus NO2 plus O2. So, to balance this equation, in the same manner we will first of all make the table. Now, in this table first of all we will make the list of the elements. The elements are, as you can see yourself, lead Pb, then other element is nitrogen, and the third element is oxygen, right. Now, we will find the F number. How many times lead is appearing in the chemical equation? Pb is occurring at one place and the second place. So, the F number of Pb is 2. Now, see nitrogen. Nitrogen, here it is appearing and here it is appearing. So, 2 places again we can see its F number is 2. Now, see the F number of oxygen at one place, second place, third place and fourth place. So, what is the frequency number of oxygen? It is 4. Okay. Again I will say the same thing, do not count the number of atoms, only you have to count the number of times the atom is appearing in the chemical equation, right. Now, find out the order of balancing each element. As I told you, we have to start balancing with that element which has least frequency number. But here again 2 elements have the same frequency number, and balancing of metal has to be done first and balancing of non-metal will be done later. So, lead is a metal, nitrogen is a non-metal. So, here lead will be balanced first and nitrogen will be balanced second, and oxygen will be third in order. To balance lead in this particular equation, first count how many lead atoms are there in the equation. You can see yourself, there is one lead atom left hand side and one lead atom on the right hand side. So, it is already balanced. Let us come to nitrogen now. Count it. How will you count? Here there is one nitrogen atom, outside the bracket there are 2. So, 1 into 2 is equal to 2. So, there are 2 nitrogen atoms on the left hand side. Let us see on the right hand side. There is only one nitrogen atom. To balance, what will you do now? Can you tell? Yes, you have to write 2 in front. You cannot change the formula. You can write a number in front of the formula and you cannot write anything as subscript. It makes the number of nitrogen atoms now equal on both sides. Now, the third element to be balanced is oxygen. Count the number of oxygen atoms on the left hand side. O3 means 3 oxygen atoms. Outside the bracket is 2. So, 3 will be multiplied by 2. So, there are 6 oxygen atoms on the left hand side. Now, on the right hand side, 1 oxygen atom. Here how many are there? 2 into 2. 2 2s are 4 plus 1 5 plus 2 7. Now, on one side there are 6 oxygen atoms, on the other side there are 7 oxygen atoms. Now, in this case, in this particular case, a rule follows. If the atom of an element on one side is even in number and on the other side is odd in number, and also the element, the atom, this is present in the elementary form. This is elementary form, not in the form of a compound, and the same element is present in the elementary form, then what will be done? The whole equation can be multiplied by 2, or rather should be multiplied by 2, except this. I will repeat, if the number of atoms of an element on one side is even, other side is odd, and the element is present in its elementary form, not in the form of compound as in these cases, then the whole equation will be multiplied by 2. Let us see what happens. If we multiply it, 2 PbNO3 whole twice 2 PbO plus 4NO2 plus O2. Now we can see how many oxygen atoms on this side. 3 into 2 are 6 into 2 equal to 12. So, this side there are 12 oxygen atoms on this side. Two oxygen atoms, and here 4 to the 8, 8 plus 2 10 plus 2 12. So, in this side also there are 12 oxygen atoms. So, we can see this equation is balanced. Chemical equation can be made more informative by writing the physical states in the chemical equation, by writing the symbols of the elements or compounds. For solid, writing S, for liquid L symbol, and for gas G, for aqueous solutions, aqueous means solutions in water, AQ. If a gas is evolved, then making a sign arrow like this, and if a precipitate is formed, this is for upward arrow is for gas evolved, and downward arrow is for precipitate formed. What is precipitate? Precipitate is an insoluble salt which is formed, which settles down. That is why a downward arrow is put behind that salt. So, in this particular equation, we can make it more informative by writing the symbols of the physical states in this chemical equation. Iron is a solid, so we will write here S. Water is a liquid, so we write here L. Fe3O4, ferric oxide, is a solid, and hydrogen is a gas, so we can make an arrow in the upward direction to show that the gas is evolved, or writing G in the bracket. Calcium carbonate CaCO3 is solid, HCl is a solution in water, so we write aqueous, CaCl2 again is a solution in water, aqueous, H2O is a liquid, and carbon dioxide is a gas. Silver nitrate is a solution in water, right. NaCl, even if you write liquid L, it is not incorrect. Solid you cannot write, because solids, if it is in solid form, it will not react. Here also it is an aqueous solution, solution in water. AgCl is the precipitate formed, arrow in the downward direction, which shows that it is a precipitate which has settled down, and NO3 is again aqueous. So, we can make the chemical equation more informative by writing these symbols.